All right, so today we're going to be talking about an overview of FRC robots. This is going to be just a brief introduction to kind of how the actual robots work and how we break them down so we can understand them into different pieces. If you have questions during it, please use the chat. I'll try to check as we're going along, but it's easier than getting interrupted for these ones. Okay, so we talked a little bit about what FRC robots were during the introduction presentation before, so we have some idea of kind of what the robots look like a little bit. We're going to kind of go down into what all the different parts are. So FRC robots, every year there's a new rulebook, so the robots do kind of change in appearance a little bit to fit the specific game and rules for each season. So there are different max starting sizes. So how like the length and width, or sometimes it's called a frame perimeter. So it's how long, like if you wrapped a string around the robot, how long that string could be. So you can kind of play with shape in seasons where it does it that way. There's also normally a max starting height. There's also a max weight. So robots weigh normally 125 pounds. There's a little bit of detail in that you don't even know about yet. Please don't use any of the annotation features. I'll have to go through and figure out how to disable it all when doing that. Okay, so from there's also normally an expansion limit. So it's how big the robot can get during the matches. So once the match starts, it has to be in some sort of starting size, but then in most games, you're normally allowed to extend parts of your robot out past kind of the starting size, possibly up to be taller and all sorts of things. So there's only some way you have to start, and you have to be able to like fold yourself into some configuration, and then you're allowed to get bigger in most games. There are very detailed specifications and rules around how the electrical systems work, what parts are allowed to be in there, how the wires work, how everything's connected together, and the same for the pneumatic system, which we're going to talk about what pneumatics is in just a second. There are also a lot of safety rules around making sure that the robots won't hurt any of the people that are working around them. They won't damage the field in any way. They won't damage the game pieces. They won't damage other robots. So there's a lot of rules around that to make sure the robots are all able to play and continue to play all season long. Like I said, they all are pretty heavily based on their season, right? Teams are designing them around whatever the task is that year. So you can, as you get used to this and you see more and more robots, you'll be able to pick out which game a robot was built for just by looking at the robot. You'll be able to go, oh, that was a robot for the 2016 game or the 2018 game or whatever it was. But part of that takes looking at a lot of robots, which is something we're going to talk about here as well. Okay, so really brief introduction. Motors are one of the main ways we get a lot of movement from our robot. They're very easy ways to make things spin. So there's a lot of tasks where we use rollers and wheels and other things that can spin easily because we have easy motors and we have ways to make them do what we kind of want and accomplish the tasks for the game. The motors require battery power to do that. They take electricity and they turn it into rotary motion. Electronics are kind of everything that we consider the control system, the electrical control system for the robot. We're not gonna go into all the details here. We'll do that actually coming up in Monday in the next controls talk. We'll go through what all of these different things are. But it's all the wiring connectors and how we get power to all of our motors. Pneumatics is one of the other ways we can do motion, and it's using compressed air to create motion. So again, we'll have another presentation that goes into a lot more details on this, but basically you have a compressor that takes the air just around the robot, the normal air, and it compresses it into a smaller volume. So you have like a storage tank, and then you can use that air to move pneumatic cylinders. So when air gets pushed in to this backside, air gets pushed in here through the animation. So then this piston rod can come out, and when air gets pushed in the front, it can be pushed back. So that's one of the really easy ways for us to make linear motion. So instead of like a motor where we have to spin things and we're getting a lot of rotary motion, for pneumatics, you can push things in and out. Yeah, so we had a question. There is a very specific battery you have to use in FRC, so every team is using basically the same exact type of battery, and you're only allowed one of them per match. So we have multiple that we charge and cycle through. So we make sure we have a fresh battery each match, but there's a specific battery that you have to use. Okay, so the idea of a subsystem is just, it's part of the robot that we can divide up and kind of say that, okay, this part of the robot does this specific task. A lot of times, sometimes they get a little bit more blurry than that, where there's subsystems that'll do kind of parts of different things. So it's not always as easy as this thing picks up balls, this thing launches balls. And there's some line, like you have to connect them all. So normally they are somehow mounted all together. But largely we can pick and choose out and be like, okay, this is kind of how their launcher works. This is how their collector intake works. This is how their robot drives. And those things we kind of consider to be the subsystems of a robot. Robots will have different amounts of subsystems and different types of subsystems based on the game, based on how the team chooses to design them. There's a really wide range of robot ability and complexity inside of FRC. There are teams who are basically, if they can get a drivetrain moving, that's awesome. It's not easy necessarily to do that if you don't have a lot of experience, if you don't have people on your team who have had experience, if you don't have a lot of resources. So they may only be able to drive around the field, but there's normally ways that they can kind of still contribute to the match a little bit. And then there are teams who are going to be able to do almost every task in the game and do it very well, and they build very pretty and complex, way more complex robots as well. So there's a wide range when you start looking at the entire field of FRC, all almost 4,000 teams now. We're going to go over several different example subsystem categories. These are roughly kind of standard. Each season, there's sometimes ones that won't exactly fit into here, but most robot subsystems will be able to fit into these. I kind of generalized them out of the seasons as much as I could. But we're just going to break down some of them and look at how the different pieces that make up the FRC robots. Okay, so the most important part of basically every robot, it's gotten easier to do this well, but for a very long time, it was really critical and it was just difficult to make a drivetrain that was reliable enough to like last the whole season, not have to constantly have maintenance. It's gotten a lot easier just because people have been doing it longer, so we've learned a lot. But the purpose of the drivetrain is to allow your robot to move around the field. There are a lot of different types of drivetrains and a lot of different things you can do to change and modify your drivetrains. But roughly they're all doing the same thing. They're translating the robot, they're taking the robot from point A and getting it to point B. And almost every game and robot requires you to do that. It's very, very rare that you can build an FRC robot that doesn't drive around the field. It has happened. There's a very few weird exceptions to the rule. But the vast majority of FRC robots all have a drivetrain. What we normally include when we say drivetrain is basically the main frame of the robot. So it's normally like kind of the bottom structural pieces, normally metal. Sometimes teams build them out of other things. The drive motors, so whatever motors are powering the wheels, the drive wheels themselves, any other parts that help get motion from the motors to the wheels. So sometimes you have gears and belts and pulleys. We'll talk about what all of those are a little bit later, but you guys should have some idea of what those are. But we'll talk about like the specific ones for FRC in a different presentation. The most common drivetrain, one that a lot of teams use, is what's commonly kind of referred to as the kit drivetrain. Currently, that is this string of letters and numbers, which is pronounced AM14U4. So it's the AM14U, as in like everyone, one for you, everyone gets one. That's what the naming was for. But basically, in the season, if you are a brand new team to FRC, or if you just don't opt out, part of the kit that you get at the beginning of the season, which kit is a strong word, it's really not a kit, it's just parts. Part of the parts you get at the beginning of the season is a box that allows you to basically build this drivetrain over in the bottom left. So it's standardized, it works, it does its function, and it does it really well, actually. So if you're, for a lot of new teams, this is by far the best option of getting a drivetrain up quickly. You don't have to design anything. You don't have to build anything. You just basically assemble this based on the videos and you get to a nice functional working drivetrain. The pictures on the right are a couple photos of Spectrum drivetrains. So this is our 2017 drivetrain in the middle. and this is our 2020 drivetrain, the underneath side of it over here on the right. So we have different tires, different motor setups. There's all sorts of different things you can do in the drivetrain, but they all do basically the same thing, which is drive you across the field. Another very distinctive part of FRC robots are our bumpers. So we talked briefly about them in the introduction meeting, but bumpers are there to protect the robot from damage and protect other robots in the field from damage from the robot. So basically, you can think of them like football pads for the robot. So we have to build the bumpers. They are relatively easy to build. They're basically just a piece of 3/4 inch plywood, like we just get it from Home Depot. They're 2 literal pool noodles, so the same type of like pool noodles you would splash around with in your pool or play to like float on or whatever. Literal pool noodles, and then fabric that wraps around that. And so that's basically the entirety, plus some sort of mounting system, depending on how you want to mount it to your robot. So they're really easy to make, so that all teams can have them. You have to be able to have red and blue, so that you can determine which alliance you're on. And that's also where we put our team numbers, so it's really easy to see and identify which robot is which. So these are ours from 2020. We have our red set and blue set, and then these are actually on the robot. So this is one of those things that just every team has to build basically every season. There's been like one exception to the rule since 2008 when it became mandatory that everyone had one. But basically every year you have to build bumpers. There's a bunch of kind of weird custom, like not necessarily weird, but minor customizations you can do. So you can like have multiple piece bumpers. You can have a gap in your bumpers if you need to like have an object come through it or something. The bumper rules are pretty extensive, and we'll at some point go through them. But for the most part, as long as you kind of meet this structure, plywood, noodle, fabric, and you don't try to do anything too weird inside of it, you're pretty okay. But the rules are extensive, and it will have teams have to like remake their entire bumpers at events because they didn't follow the rules right, which is frustrating, but there's reasons for it to make sure all the teams are safe when they're interacting. Okay, so the next subsystem that's pretty common to robots is what we call a floor intake. Kind of based on the name, you should be able to kind of tell what it does. Basically, it's not literal, it doesn't intake the floor, it intakes game pieces from the floor, is why we call it a floor intake. Some games, it's just an intake because there's no other option than to pull the game pieces from the floor. Other games, there may be another way to acquire game pieces, which we're going to look at in a second. So then you have to split them. But basically, yeah, the entire goal here is to move game pieces from the floor into the robot. Most of the time, it's either going to be done with some type of wheels or some type of roller. So in this picture on the left, these wheels here spin and these wheels here spin, and they spin in opposite ways, and they suck in this like cube. We'll see it in a little bit. Actually, I have a GIF of it working here in a second. And it picks up a cube, so then the robot could score it in one of the games. This was a 2018 game. And then this is our 2020 robot, and this is a earlier version of the 2020 robot that is picking balls up off the floor. So you can see it very quickly as these wheels roll in. As the ball gets there, it gets sucked right into the robot without having to do anything. So like in this prototype version, the ball's kind of rolled to it. On the real field, the robot would be driving around and running into the balls and having them get sucked up. The other type of intake in most games, or in some games, is what we call a human feeder intake. So instead of having to pick up an object off the floor, in a lot of games, you'll have some sort of area where a human can drop or slide or push or somehow put a game object onto the field at some height, and then your robot basically just like catches it. So it's a little hard to see on the back of this robot because it's all made out of clear plastic. But there is basically like this shelf right here, the sort of like ramp, where the gear is able to come down and get slotted into this little holder right here. So this is a 2017 game. We'll talk about more like what you actually have to do in these games later on. But for now, just know basically this human feeder intake on the 2017 robot was able to catch the gear that the human player would slide down the ramp right there. This isn't in every game. Some games have it, some games don't. Some days you can kind of like incorporate your human intake into the same thing as your floor intake. So in the 2020 game, there was a human station, but we just had balls like kind of come right over the top of this. So when this is down, balls could just be fed right into the top of that. So we didn't have to build like a separate intake or anything for human player. Next step. So once you have a game piece, depending on the game, if it's one where you have multiple game pieces, sometimes you only have one, sometimes you have multiple. If it's one where you have multiple, you normally have to have something inside your robot to store those game pieces and sort them and move them through your robot somehow. So normally this is somehow called a hopper or an indexer. Some name like that. Different seasons will have slightly different names. But in 2020, they were normally hoppers or indexers. But you can see over here in the video here, after the balls come in, they're able to like be brought up into this tunnel in this straight line. And there's also this kind of like side belting that you can kind of see this black thing as a belt to kind of push them towards that center path. So that sorts them all for us so we can get them all roughly in a straight line and we can move them to the launcher that's above it, which we're going to talk about next, I think. Yep. Okay. So kind of now that we've brought in game pieces into our robot, we've sorted them, we need to do one of the tasks. And in a lot of games, those tasks is launching the game piece into a goal. So one of the easiest ways to do that is a wheeled launcher. So here we have this white wheel right here. There were a bunch of those little green balls that you saw earlier in the video, green or yellow balls, and they would be down here, and we'd bring them up and we'd launch them out of this launcher. This is a close-up of the 2020 wheeled launcher. So these two wheels would spin really fast and launch the balls that you see over in that video on the right. Similar concept to like a baseball pitching machine or a football pitching machine or any of those types of things where you just spin up a wheel, you have the object kind of touch it and it gets launched through. So yeah, you can see here, you can see the finish of like the funnel or the hopper and everything where the balls go up that belt and those two that are left get sorted to, and they all spin up really quickly and out the robot into the goal. So in 2020, our job was to shoot the ball into this goal, and the robot did that pretty well. And this was one of our pretty early testing videos as well. The competition robot got better than this actually. Okay. Another way in some games that makes sense to launch game pieces is with a catapult. So our 2014 robot was one of the few that had a catapult of some kind. The 2014 game involved these big yoga balls that you had to launch. And since it was such a big object and your robot was only ever holding one of them, you could do it with a wheeled shooter, and some teams did. But one of the most common ways to do it was with a catapult. So here over on the right side video, we actually have 3 different catapults launching. You can't see this one, it was cut off in the video. But these two you can see. So this was 4587, which is Jersey Voltage, a team out of Jersey Village. So they have their catapult launching, and then ours launches as well. There's a ton of different ways to power catapults. You can like pull springs back. You can use pneumatics. I believe our catapult in 2014 was definitely pneumatic. So we used 2 air cylinders to push the catapult arm up quickly. I believe 4587's was spring powered. They like pulled back. They used a motor to pull back their catapult and tightened a bunch of springs. And then when they released it, the springs fired the catapult. There's a variety of other games, but a lot of times when you have like a single game object that you're holding, a lot of times catapults can work for that. If you have a bunch of objects, it's a little bit harder because you have to reset it every time, so your shot's going to be slower. Okay. The next subsystem is the elevator. This is very common in a lot of games. So one of the things that FRC game designers like to do is make us score objects at different heights. And so one of the easiest ways to have your robot do that is to build your scoring mechanism onto an elevator similar to like what a forklift would have. It lets us take a game object like you see over on the right. We have this like hatch panel from our 2019 game, and our elevator and our robot can just raise it up and put it on the highest scoring platform or the highest scoring goal for those hatch panels very easily. There's a variety of different ways to build elevators. They all kind of do the same thing. So we're not going to go into those details yet right now, but just know that there's a lot of games where building an elevator and being able to do it well is very valuable to building a really good robot. Another way to get height in FRC is with an arm. So this is the only arm we built, which is a little bit of a kind of interesting, different design than a lot of people, what we normally would consider an arm. So this one pivots in the middle. So it's basically using rotary motion to elevate the game piece. So this one was kind of an arm with an elevator combo. Basically, this could rotate up, and then the whole center section of this could actually extend. I don't have video of the extension right now, so you could get a lot taller because you could rotate up, and then this would basically extend out about 3 feet or so. So if we had to score in a higher goal, we could with that like extension motion. Here's also the 2018 intake working. Those wheels go around and grab that cube and are able to pick it up. Okay. Another really common part of FRC robots are any type of wrist or kind of basic pivot mechanism. Largely just a smaller arm. Sometimes they can be done with pneumatics instead of a motor because you only need like 2 positions. So you just need in and out. So the example over here in the bottom left, if I can get that to go away, the intake gets pushed down with pneumatics, and then it's able to be brought back. So it kind of just rotates 90 degrees up and down. So that's a small little wrist or pivot. On the right, it's a little bit harder to see. There's somebody standing in the way of it. This is the best video I could find. But basically, right at the front here, there's that little platform. It drops down. It picks up that gear from the floor, and then it's able to come out, and it kind of pushes it out again. So that was powered by a motor, so it could have different positions. But it can basically anything that's going to like push out. A lot of time it is to bring an intake down, something to reach outside of your robot. A lot of times we'll use a wrist or a pivot to do that. You'll also find them mounted onto elevators. So a lot of times you'll have a wrist on your elevator so you can still reach out and grab an object and like fold it back up and take it up to where it needs to score. There's a lot of combining of all of these subsystems in different ways depending on what the game requires. Another common example that gets used in a lot of games is some form of climber. These all kind of look different depending on what the game task is specifically. There's a lot of different climb tasks that we've had in different games. But the main objective basically stays the same. You're trying to just raise your robot up to some certain height or off the ground or to meet some requirements based on whatever the game is, normally at the very end of the game as part of the end game. Which is just a normal way, like it's just like this last way to get points during a match. Regularly, you have a climber that basically just kind of looks like an elevator. So you send the couple hooks up. The hooks, you kind of drive into the bar, you grab onto the bar, and you just do a pull up with the elevators. You just run the elevator in reverse, and your whole robot gets lifted off the floor like we're seeing over in the right. This is a very common type of system. They all have kind of different tweaks and things based on the game, based on which bar you're grabbing, because the game might be a little bit different. But 2020, 2018, 2016, 2013 all had similar type of end games where you just had to like reach up and grab bars to be able to get your robot fully climbed. Another common example is being able to use like a winch. So if you didn't want to have a whole elevator that was strong enough to just pull your whole robot down, you could have a much smaller, lighter thing that could deploy a hook up onto a bar, and then you would just have like a cable and a winch, and you would just winch your robot up to do the climb as well. So that's another common way to do it. Depending on the game, there's some variety of climbers and things. 2017 had a rope climb where your robot had to like grab a rope and then spin itself up. And just like climb the rope, which wasn't nearly as hard as it actually seemed, because again, it's just a motor, so you're just spinning. There's a bunch of different climb tasks that have happened in different years that we'll go over as we start introducing more and more games and looking at the details of them. One of the last types of subsystems is the field manipulator. So these are really game specific. So there are times where, depending on what the game is and how the game works, FRC will have us interact with some portion of this field to allow either the robot to do something, to get over some obstacle, to move some part of the field to score points. There's a variety of different things you can do in different games. And a lot of times you have to build some sort of mechanism to do that. So in 2012, there were these big teeter-totter bridges that had to go up and down. So a lot of robots had a way to push a side of the bridge down, like a side of the teeter-totter, so they could drive up it. In 2016, that's what these two robot photos are from. This is team 118 from 2016, and they have their little wedge devices out here. This is our robot from 2016. We used our intake and kind of built the wedge into the side of the intake. And basically we had, the way this worked is this platform would be tipped the wrong way. We could use our wedge to kind of bring it over on top of it, and then our robot could drive up this ramp basically that we would make for ourselves. So like in 2016, you had these defenses you had to cross and get over. There were also doors that you could like open and close to get across. The 2016 game gets a little complicated. We'll go through details of that at another time. But there are a lot of different ways to manipulate the field that year. In this past year's game, if any of you watched the game animation that I sent out in the Slack, there was a control panel that you had to be able to spin to either spin it a certain number of times or spin to a certain color. So your robot had to have a way to like move this control panel big disc that was on the field and set it to where you wanted it to be. So that's another way that you could have a field manipulator type object. Or type subsystem, sorry. Okay. Any specific questions about the subsystems we went over? So one of the hardest things now is once you kind of have an idea and you have a few examples of what some of these are, as we start wanting to actually think about how we design robots and how we build robots, one of the biggest things we can do is to look at a lot of robots. And one of the ways we do that is with what we built out as our mechanism library. So it's part of our photo gallery. It has its own link that you can go to, which is mechanisms.spectrum347.org. Let me switch off. Oops, maybe not. All right, we're going to switch the screen share real fast. Give me a second. And this will let us look at some of the robot mechanisms. Okay. Yeah, we can do that. Okay, so the mechanism library is built into different years where we've tagged photos and we've tagged the subsystems as well. So we kind of can break it down and look at specific subsystems from specific years when we want to get design examples, if we want to just kind of learn how different teams built things and get inspiration on how to do the same type of things ourselves. Like there's a lot of learning from what other people did and what other people either did successfully or even necessarily, maybe they didn't do it quite right, but they had a really good idea, they just didn't implement it quite really well. So there's a lot of advantages to looking at a ton of robot photos and videos and explanations and diving into how other teams do their, how other teams solve the problem. So then you kind of get this library of solutions built up that you can refer back to, right? So you don't have to necessarily know exactly how someone did it, but you can have this vague idea that you're like, okay, this 148 robot from 2016 did this thing this way. Maybe we can go back and look at that and use it to solve this new problem that we have. A lot of what you want to do, especially early on, is to get a broad exposure to a lot of different robots and how they were built. Looking back at how we built robots, because you guys don't actually have all the details of our past robots, is another good way to see all the different things we've done in the past. But looking at other teams helps too, so you don't just get locked into like one design philosophy or anything or one way to do things. So we can look at some of the 2017 examples. We have quite a few in here. So they're all broken out into their subsystems, right? So we have 2017 climbers, 2017 drivetrain, electronics. There were two different game pieces. So this is a floor intake, but specifically for the gear in 2017. There were also floor intakes for the balls in 2017, what were called fuel. So those have 2 different categories, so there were 2 different game pieces. So they're both floor intakes, they're just 4 different objects. This one we called serializer, which is basically just the hopper indexer. Like I said, there's different names based on kind of what people use during the season. Then there are a few different types of shooters. We didn't specifically talk about turrets, but that is another, it's normally part of a launcher of some sort, but it allows you just to aim specifically the launcher instead of having to turn your whole robot. You can just turn the launcher itself. So there's a bunch of different photos of different turrets in here, and you can see exactly how people built all of these different turrets. And if we needed to design a turret, you could look through all of them, get a bunch of ideas, and then start thinking about which ones do we want to implement. Okay, so let me get up to 2020 real fast. So one of the things we do is we have a lot of photos, but they're not all tagged yet. And part of that process is actually doing the tagging is to see a lot of robots and get exposed to a lot of different robots and a lot of different design ideas. So these are some of the 2020 robots that we competed with at our one event in 2020, which was Dripping Springs, which is out near Austin. So ideally we would go through and we would figure out, okay, what parts of the robot are here. So this one was tagged with intake, drivetrain, control panel, which was this field manipulator. So that was the part that had to like spin that disc. And that's this green wheel right here. And it was tagged with the year, so 2020. So we see that there's a drivetrain here. We see the intake. So this like roller up here is how they brought balls in. And we see the control panel. So that's all it was tagged with. And that's probably reasonable. If you wanted to, you could tag it with like pneumatics or electronics. But if you miss tags, if you're going through and helping do this or doing this as like an exercise, it's fine to not be 100% correct. We just want to get most of the things in there. So it's easier for other people to come back through and look through as well. We can see some other ones. This one has intake and control panel. So this was how they brought balls in. And this is like a photo just specifically of their intake. And then this little wheel up here they used for the control panel. If you didn't like notice that or know that, it's fine if we miss it. Because a lot of times we'll do this after we've like just gone to an event with a team or something, so we've seen how their robot works, so we know a little bit more about it. Let's see. Yeah, so this is the 118 robot. So this is where we get to a lot more complexity. This is one of the best teams in the world almost every year. They're down in, they build out of the NASA Johnson Space Center down in Clear Lake. Where here we can see they have a turret, so they can move their launcher around. They have their shooter. They have a climber. So these poles right here are how they hook onto the bar. The photo kind of cuts off at the top. Basically, this whole bar, these tubes extend, and that's how they do their climb. We have their drivetrain, all the wheels here. We have their intake. So back here, you can see like balls would come up, get rolled into their robot over all of these rollers. And then we have control panels. They use this like really wide belt for their control panel mechanism to be able to spin that little wheel. And then we also tagged it with electronics because you can see how all the electronics are kind of mounted up right here. Okay, so we're about 440, cool. So what we're gonna do now is see what we would tag some of these robots with ourselves. Let me see if that makes it. Okay, so if we were looking at this photo, anyone have ideas for what we would tag this photo based on any of the subsystems we already listed out?
Electronics.
Cool, I agree. There it is. Anything else?
Drivetrain?
Yeah, so we have all the wheels. So the drivetrain is what they're going to use to move around the field. So this would be drivetrain.
Mechanics?
Was mechanics one of the subsystem we had anywhere, right? So it wasn't one of the things we listed, right? So almost everything on the robot is mechanical, so we don't have that as a category. We have electronics because it's mostly about like how do you mount the specific type of electronic elements, kind of the main electrical things. If there was just a photo with like just a motor, we wouldn't put electronics normally.
Intake,
Control.
maybe?
Intake, yeah. So it's a little bit harder to see on this side profile. We'll look at another picture in just a second. But so this right here is their intake. So it's kind of like the side, and they have these rollers. And when it's deployed, they would bring that up. That was how they would bring the balls in.
Control panel.
Where do you see a control panel mechanism?
Is that not the what's it called, the belt? Some on either side.
Oh, I got you. No, so it's not. So, so this is one of those ones where you just have to sometimes watch a lot of the game. So what this does down here is similar to what our belts do in this picture. So you see them come down in right here. So it's those belts there that kind of feed the ball into that tunnel. So it's part of their hopper indexer. So it kind of helps sort the balls into a straight line. So we would do hopper here, or indexer, whatever we want to call it. Like we have specific tags per year that we'll go through, but they're roughly these. So yeah, so if these are bringing balls in, there should be, what do I see? So there's probably like at least 3 other tags that would be on this because this is most of their robot. One you probably won't see until we see the second picture in a second. The
Turret?
other 2. So it doesn't have a turret. So so there's no place where this is going to be able to spin. So that's a little trickier because yeah, you can see that it's going to launch the ball somehow, but you have to know if it's going to be able to like rotate. And there's no place in here that it's going to be able to like rotate. This panel is basically solid. So it's a little trickier. And if you do this on your own, which we'll talk about how people can do more of these, because the biggest thing is you just have to get experience doing them. So even being wrong is fine. Like, well, catching the wrong ones is a lot easier than not necessarily having them all done. And so having more people do different events and looking at a lot of robots is super beneficial. So the 2 others that I would definitely say are in this photo is a wrist. So we talked about how this is the intake and it has to fold down, right? So there's a way for this to fold down at the beginning of the match and during the match, and then they're to bring balls up. I don't actually know where it's powered. That's a different problem. We'll figure that out later. But it definitely folds down. We know that much, so it's a wrist. And then the other object is the shooter. So this wheel right here is how they launch the balls out. So similar to the same way we do, this robot's just shorter. This will spin up to a really high RPM, and it'll launch balls out. Wheeled launcher is fine. Okay, so this is the opposite side of that robot. So we can see the other side here. So a lot of them are going to be the same. So we can see that the intake is up here in the same spot that we saw before. We can see the drivetrain again. We have all these wheels. What else can we see again, or what else is new?
Elevator or the arm?
Yeah, so this thing
Can you
back
just
here,
go
right?
back a
So we
bit?
got to figure out what this thing back here is. So it is an elevator. So yeah, so this is a bunch of different stages, and this would extend up. But so because we know what this game is, we know specifically that this is their climber, not just an elevator. So in this year's game, we would call it climber. In other games, we might call it elevator. Normally, kind of like the difference is basically elevator is used if we're like using it to pick up a game piece and like raise the game piece to some height. It's an elevator. If it's just going to pick up the whole robot, it's normally part of the climbing mechanism or climber. That's normally just like the jargon, right? If you said one or the other, people would probably figure it out. The other part, we have the same belt again. That was part of their hopper, so we know that their hopper is there. I think that was the biggest piece. This is what the battery looks like, by the way. We probably don't need to put electronics in this one to tag it if we were tagging it. But this is roughly what a battery looks like. Sometimes there are different colors. You might see an all black one, you might see an all gray one, but this black and gray object is basically the battery. which we'll look at more if you come to controls on Monday. Okay. We have a couple more examples that we can go through quickly, and then we'll talk about how people can do more of these on their own. And it's like I said, it's totally fine to just list the things you know. So if all you see in here, you're like, okay, I know there's a drivetrain and I know there's electronics, and that's all you tag when you're going through it, that's totally fine. It's also fine to be like, hey, as you're looking through, you might post one of these into the design channel or anywhere or somewhere else in our Slack. Design channel is probably the easiest, and be like, hey, and you could like circle something and be like, hey, what is this? Is this their intake or is this their shooter? I'm not really sure. Asking those questions and like getting conversation going about robots is great. The more you're like looking at and trying to figure out how robots work, the better. Because it takes a while to kind of get all of it absorbed in to be like, okay, all of these robots do different things. They all look different. Because again, all of these robots are designed to play the same game, right? They are all playing the same game. They're just built by different people. So here we can, if you have the presentation up, you can look at the photo a little bit easier and zoom in a little bit. So we have, like I already said, so we have the drivetrain, right? So this is what the kit apart drivetrain, the AM142 drivetrain looks like when it's actually fully built out. This is what some of the pneumatic components look like. So this is the compressor. These are some other parts that you need for pneumatics. We'll talk about a little bit later. So we probably have pneumatics listed there. And then we have some other parts of the robot. So we have this thing, which, anyone have any ideas what this is?
Is that the turret?
So I don't think it rotates. I'm gonna go with no, because I think if this whole thing rotated, it would hit these objects. So it probably only like tips up and down. So this is probably their shooter, is my guess. I'm not entirely sure how they would get balls into it. So it may only like shoot the starting. So you get 3 balls to start the game with. So they may just like load those 3 balls in and only shoot those. I don't think there's anything on the back for them to be able to load or anything like that. So they probably don't have an intake, which is fine. And then anyone know what this thing up here are? So we have these like wheels, and these, what does it say? It says dart actuator on it. Anyone have any ideas what these could be
Is
for?
it an elevator?
Yeah, so it's an elevator-like thing, but like I said, in this game, almost every elevator is their climber. So what they're gonna do here is this motor spins like basically like a screw that's inside of here, and it allows it to extend. So this is like what's normally called a linear actuator. They don't get used all that often in FRC, but it is a thing that can be built, or in this case, purchased. So this was something that they bought. And then these wheels up there allowed them to like grab the bar, and then their intent was to be able to actually like drive back and forth or like slide back and forth on the bar to position themselves. I'd have to go back and look at video to find out if it worked, but this is definitely their climber up here. This is their attempt at a climber, if it worked or not. So what do we have? So we have drivetrain, we have pneumatics, we have shooter, and we have climber. I don't think there's anything else that's super important to tag in that one. Okay. Last one we'll do as a group. Anyone see anything they want to tag in this?
Driver. Bumper.
Drivetrain, yeah. Drivetrain, this one has their bumpers. Anytime you can tell for sure what team number something is, you normally tag it with the team number. If you're actually going through and doing it. So we would tag it with FRC : or actually I don't think we do that. I think it's just the team number 6357. I have to look at our tagging standards ourselves. Yeah, so we have drivetrain. So these 3 pneumatic wheels that you can see down here are part of their drivetrain. The other bits are inside it. We wouldn't be able to see that, but that's fine. The bumpers are going all the way around it. Team number. What else do we see?
Floor intake.
Yeah, floor intake. So these rollers, I'm actually not sure how their floor intake works. That's a different question.
Electronics, you can see a bunch of wiring.
Right. So normally if you can like, anytime you're like, you can sort of see it's totally fine to just not put it. Because ideally we want to be, anytime we're like looking through the tags, we want like pretty big examples of it, because we're like, oh, we want to know how everyone mounts their electronics. So we would be looking for examples of like specifically that, where it's like, oh, you can kind of see what's happening, because you'll almost always have a wire in almost every robot photo. So it's really like, okay, they mounted all of their electronics and we can kind of see it all. So that's where we have electronics. My guess is intake is there, but it might be on the back. This would be one where I'd try to like, a lot of times we'll have more than one photo, so I'd often like look at more photos to just be sure, because I'm not really sure how this gets a ball, right? Like, does this extend out somehow? I don't really know. And it's hard with still images. This is tricky. It is not easy all the time. Many times I'm not sure either when I'm going through. So if we're not sure about intake, what else can we be sure of?
Is that
Shooter?
like a shooter? Like
Yeah.
the
So
thing that-
yeah. So the shooter's this blue wheel right here where his hand is. So this is going to spin really fast, and the ball's going to come up and exit where his hand is, out that way. And then the last part, which is definitely trickier because we haven't really talked about this type of climber. So these like rails right here that fold and everything, these are their climber. This is their climber. I don't know. It's one, but it's plural. That's confusing. Okay. So the way you kind of tell is this thing right here is a hook, and the only thing you needed a hook for in this game was to climb. So a lot of times having video and stuff makes it easier. You can kind of tell what people actually did with it. And having just you get a lot more experience once you look at all the games and know exactly how, once you see more robots, it's easier to identify things on other robots when you see a lot more robots. So climber would be in this one as well. Okay, so if you are interested in doing more of this photo tagging stuff and learning about robots, like I said, this is one of the best ways to get a deep understanding of how robots work, is to really look at a lot of the photos. We'll have a lot more video and stuff too that we'll put out. There's a lot of video where teams like kind of walking you through their robot and walking you through how the different parts of it work, which we'll start posting more of now that we've gone through all of these subsystems. But tagging photos is definitely useful. So I don't want to go through it with everybody, because if you don't want to do it, there's like a password, and it definitely takes some time. It takes a little bit of time, and we'll go through more examples together when we do it. And it's kind of individualized, so I'm like assign specific galleries to people so they can go through, and we don't like have people doing the same ones over and over again, because then they're already tagged, and then you try to do it at the same time, and it just gets weird.
Could we possibly have access to this PowerPoint?
Yeah, you already do.
Oh,
Everything's always in the Google Classroom. Everything's yeah,
Okay.
it's been linked multiple times. It's in Google Classroom. Yeah, anything I present as much as I can will already be in Google Classroom. And then this video will be linked there too to the same thing, so people can go back and look at it too. Okay, so yeah, so I'm gonna go ahead and end for today on the recording. If I can figure out where the button is.